My name is Sandor Dargo, and we are going to talk about why clean code is not the norm. And what that covers, well, we'll discuss later. First, let me introduce myself briefly. Does this work? Yeah, just like the microphone, I had to turn it on. It's not mine, because I forgot this at home. I forgot mine at home, just like the power adapter. So it's not very successful. So let me introduce myself. My name is Sandor Dargo. I work for Spotify. As you probably heard yesterday, I changed jobs just last year. I'm still quite new there. I spend a lot of time writing my blog. It's mostly, but not only, about C++. And, well, I like to travel a lot, and I'm really interested in gastronomy. So just for the sake of sharing some fun detail, in a few months, I'll be a semi-professional sommelier in France if all goes well. But I will stick with C++, at least for the time being. We'll see how it goes. And I'm a fortunate father of two very active kids. They're really nice. So let's briefly talk about the agenda. What are we going to talk about today? First, we are going to discuss what is software quality. Can we define at all software quality, or maybe is it impossible? Then we'll see what is clean code, if we can. And we'll discuss how they relate to each other, or do they relate to each other? And then comes the big question, why don't we write clean code? Or why don't we write all the time clean code? What are the reasons behind? And at the end, what should we do with it? What's our job? So that's about the agenda. Now I want to share a bit my motivations, like why I chose this topic. It's because clean code is not the de facto standard, whereas, well, I think it should be. Now, it doesn't mean that we should always write clean code. We'll discuss that later. There are cases when probably it's not the right thing to do. Developers cannot agree on what quality is. That's also one of my motivations. And thanks for joining, Phil. I will refer to you quite a lot, I think. And, well, third motivation here is that people prefer, well, blaming over taking responsibility. I don't think it's good. And we'll discuss what else we can do than blaming. So, first question, is clean code part of software quality? Who says that it is part of software quality?
Define clean.
We'll define it later. So, who thinks that it's not part of software quality? There are quite a few. Okay. So, now let's discuss what is software quality. And then comes the question, is software quality a meaningful term? And now I remember your talk, Phil, about Zen and motorcycle maintenance and software quality. And you shared an article from Derek Jones, and it's called The Aura of Software Quality. And there he said that, well, it's something different for everyone. Therefore, it's not a meaningful term. It's just a marketing term because, well, if I ask you what's software quality or I ask you what's software quality, you will talk about two different things probably. And then it's really difficult to actually talk about quality because we don't mean the same thing by that. So Derek Jones says that quality is sort of undefinable, but at the same time, you recognize it when you see it. If you heard about that quite famous saying, it's pretty much like hardcore porn. You cannot really define it, but as the Supreme Court Justice said in the US, well, you recognize it when you see it. And it's pretty much the same with software quality. When you look at the quality software, well, you feel, okay, this is good. This is quality. And after I went home from, was it last year? After I went home from cpponsea 2022, I bought the book Zen and the Art of Motorcycle Maintenance, and I read it from cover to cover, and it's a very great book. I really recommend it. It talks, Robert Pirsig, the author, writes a lot about what quality is. And in this book, he has two main approaches. Now, well, he had other books with even more approaches, but for me, that's a bit too much, at least too much to comprehend here and discuss. But I want to share his two approaches from this book. The first one is the classical quality. And it's mostly about the engineering aspect, the internal aspect of a product or software product. And it's about how things work on the inside. So that's the classical approach. And then there is also the romantic approach, which is about how things are used. And it's also about their external design, the aesthetics. Now, here I have to say external design because we also use design as like the internal design of the software, its architecture. So it's about the external design, the aesthetics. Now, let's remember these two approaches and also the color codes. So orange is classical quality and red one is romantic. So then let's go to software quality. What is software quality? And if you go to Wikipedia or you just Google it, you will find tons and tons of different definitions. ISO says that software quality is capability of a software product to conform to requirements, while for others it can be synonymous with customer or value creation or even defect level. So I think this is more like a romantic approach because, well, it's about customers and value creation, not really about how it works on the inside. If you check ASQ, it says software quality describes the desirable attributes of software products. There are two main approaches exist, defect management and quality attributes. And this, I think, is more the classical approach. Now, if we take a third one, that's quite simple, from Tom DeMarco, he said that the product's quality is a function of how much it changes the world for the better. Now, that's clearly something romantic, from I think from all the different aspects. So you see that even here we have many different ways. And you can find more definitions. I don't want to bore you with them. Except for one more. The Consortium for Information and Software Quality, CSIQ, defines 4 pillars of structural quality. It says one is security, second one is reliability, third one is maintainability, and the last one is performance efficiency. Now, if you think about this, I think that these are mostly about it's mostly about the classical approach. It's mostly about how things work on the inside, not how they work from the outside. It's not about their aesthetics. So this is clearly a classical approach, and I think, well, we are C++ developers. It's very often that we more think about the classical approach because, well, not all of us, but many of us, well, we don't even see like any aesthetic interface or interface at all. So let's just take the classical approach. And now let's see what is clean code. Can someone define here clean code in like one sentence? Short sentence.
Clean sentence.
Clean sentence. Yes? Phil?
Code that's fit for development and fit for production.
Code that fits for the developer
And fit for production.
and fit for production. Okay, that's going.
Written in the clean language. There is one called that.
So a clean code that is
Written in clean language.
written in a clean language.
Still like one.
Well, but I still think that you can take clean language and write unclean code, probably.
Very difficult. It's like Haskell. It's very
Oh, that's very difficult to read for me, but that's more about me than Haskell.
code that pleases the reader.
Code that pleases the reader. Yeah, I'm not so sure about that one, because there are some masochistic people. Like, they enjoy painful things. Yeah?
Low number of WTF moments. So
Low number of WTF moments. Okay, I like that one. Okay. Yeah, I see two more hands.
Code that's self-explanatory.
Code that's self-explanatory. Okay.
And easy to maintain.
And easy to maintain. I like that a lot. I think that's really close to what we are going to use.
Yeah, mine was similar. That it conveys the intention very well and it's concise.
Code that conveys the intention and concise. Yeah, I think these two are really close to what I chose. Code that is easy to understand and easy to read. And I found this definition on the blog of Gary Woodline. And then comes the question, okay, easy to understand, easy to change, but what should be easy to understand? So we have to break it down. It was a simple sentence, but it's not necessarily so easy to understand just like that. So it should be easy to understand the execution flow of the program. That's one thing. It should be also easy to understand all the object relationships in that piece of software, the roles and responsibilities of the different classes and functions, but also it should be easy to understand the purpose of each expression. So it starts quite from the top, but it goes quite deep into the code. And probably, well, I guess in some cases you can sacrifice probably the last one, the purpose of each expression, especially like well, we are at the C++ conference, and usually at the C++ conference, there is at least one lightning talk where someone explains that, hey, it's so easy to print something to the console, but it's so slow. So I refactored it, I optimized it, and now it's 100 times faster, but nobody understands it. And those are fascinating talks, and those people know much more about the language than I do, and sometimes that's necessary, I think. There are cases when you have to sacrifice the cleanness of the code, but in most cases, I think it's not necessary. Then, what does it mean that code has to be easy to change? When is code easy to change? Well, I think that code is easy to change when the classes have concise public interfaces, because, well, then you don't have to update so many different. You don't have to update so many different APIs. Then the code is easy to change when it's easily testable, but it's not enough. It also needs to have tests because, well, maybe it's easily testable, but if you don't have tests, then you cannot really change your code with a high confidence. Then the classes and methods should work predictably. And, well, they don't only have to be deterministic, they also should work as it's expected. Because otherwise, well, it's difficult to understand what goes on. And then classes and methods should be small. and they should have one single responsibility. Now, I don't want to get into a discussion what the small mean, because probably what is a short or long class means a bit different for everyone, but again, it's probably like software quality. Like, it's hard to define, but you just feel. You see a 3,000 lines long function, yeah, you know that it doesn't satisfy this criteria. Okay, so now we know what we mean by software quality, at least now here today, and we know how we define clean code. And then comes again the question, is clean code part of software quality? And that's a question that I often asked in previous teams, and we discussed a lot. And there were always people who said, well, no, it's not part of it. Because as long as the code works without bugs, it's okay. Because the user won't see it anyway. They don't really care. And clean code is simply fun for developers. Now, what I found funny is that those developers who say that it's just fun for devs, they usually don't find it very amusing. They don't like to make this fun with themselves. But anyway, for others, clean code is part of software quality. And why? What are the reasons that we say? Well, it helps reducing the number of bugs if you write clean code. And that increases the reliability of the software, which is part of the CSIQ criteria. Then it also helps reducing the time to fix bugs, which increases the maintainability. Again, think about the CSIQ 4 pillars. It decreases the maintenance costs, which is good for everyone, good for the developer because they don't have to spend so much time on it, and good for project managers as well. They don't have to spend so much on maintenance. Well, we could talk about that a lot. And it's part of making a job right. And we'll see that making a job right is really important. And it's often more important than making the right thing. But we'll get back to that later. So we already saw many good reasons why clean code should be considered as part of software quality. Yet, it's often expendable. Why so? What do you think? Why do they sacrifice clean code so often?
It's only a prototype.
Sorry, I couldn't hear.
It's only a prototype.
It's only a?
Prototype.
Okay.
You're getting thrown away anyway.
Yeah, that's true. It's only a prototype, yeah.
It's not easy to measure if your code is clean.
It's not easy to measure. That's definitely true. Yeah?
There's a misconception that it takes longer.
That's also true. Okay. Clean code is costly. It's a misconception, as you said, Phil, but it's also true somewhere that it is costly because it requires a lot of attention from the developers. It requires effort to write clean code, more effort than writing, let's say, ugly code or bad code. It requires also care. And, well, people often don't care. It's just, they just want to get through and get the paycheck, and who can blame them? And it requires time. At least in the beginning, it requires more time than writing bad code. And these are things that usually the business doesn't want to pay for. They don't want to pay for your attentions, efforts, whatever. They're not ready to pay for this until they realize that it's too late. And quality is often lost somewhere in the midst of different constraints. So here you see this triangle with three angles like scope, time, and cost. And usually, if you want to move one of these points, it will impact the other two. So you might have to decrease the costs, and well, maybe it means that you also have less time. You have to cut the scope, but we can play this with the different angles. But there is something in the middle. There is quality that is usually not discussed, that is usually invisible. And when people realize that, okay, there is quality as well, they say, okay, so we should just sacrifice that, because most people, well, they don't really care about it. They care about the time. They care about, oh my God. So Chrome wants to relaunch. Very good. But it said I have 16 hours to finish the talk. That's great. So quality is usually the first sacrifice, because, as we already said, no end user cares about the quality of code. They cannot care less, even if the product is like a library for other developers. Probably they will not check the implementation details. They don't really care about the aesthetics of code, the beauty of code, the elegance of code. Who cares about it? Well, not a lot. But what they care about is solutions. Users want solutions to their problems. And when do they want it? All the time, yeah. Today, tomorrow, yesterday, they want them every single moment. They want the solutions, and they are right. That's what they need. But I still think that clean code is not just an art for itself. It's not l'art pour l'art. Because what will happen if you start writing bad code? Well, in the beginning, it will be fast. It will be faster than writing clean code. But then, by time, well, the productivity will go down. The number of bugs, it will increase, and it will be more and more difficult to add new features. So the productivity will slow down, and then what happens? Well, that's the end. That can be the end of a software company. I forgot to note the name, but there is a company, I think in the 90s, they had some really good debuggers. I can't recall the name. I'll share it on Discord.
Maybe soft ice?
I don't know. No, but maybe. So there was this company. They had a really good debugger. They had good software, and they just couldn't keep up with the competition because their code was crap, and they couldn't add new features fast enough. So at the end, well, they had to close the company because others just wrote better software faster, and they couldn't keep up. So the lack of clean code actually killed a very good company, and they are not the only company. We could find a lot of examples like that. So again, is clean code part of software quality? Well, I think so. I think it is. And there is this very interesting slide from a presentation that happened 10 years ago. It's Ellen Kelly who made it, and I stole this idea from you, Phil, from that talk, because I found it fascinating. Like, it's based on a research, and the question was, what is more important? To do the right thing or to do the things the right way? And if you ask people, they'll often say that, well, probably to do the right thing is more important. It's better for the business. Well, obviously the best is if you do the right thing the right way. But probably doing the right thing is more important, right? And Well, based on the data, most probably it's not the right answer. Because if you check this, you'll find that, well, if you do the bad thing, but you do it in the right way, then in a 3-year time span, you will spend less and you will make more money compared to those who did the right thing but not the right way. And the reason behind is that, well, it's very difficult to change how you do things. If you do things always the bad way, it's very difficult to change it. But if you do things the right way, well, it's actually quite easy to change what you do. It's easier to change what you do than changing how you do things. That's why you should focus more on having the right habits, on writing clean code. You should focus on doing doing the things right. And then, eventually, you can fix what you do, if that's still a problem. So, in that sense, clean code is part of software quality. And making the job right should be a responsibility for all of us because it pays off in business terms, even in the midterm. Maybe not in the short term, but 3 years is not so long. And it's more important, again, just to emphasize this, than delivering the right thing. So, we don't do it often. Who is guilty? It's me. Yeah, well, I asked this question, probably it was on LinkedIn, I'm not sure. And there were many different answers. I started to analyze them and put it in different columns and okay, let's see the different patterns. And well, most people said it's them project managers, right? Because, well, they build a factory. They treat us as factory workers. They just see a software factory. They want us to keep delivering new and new features all the time. And, well, they don't understand what technical debt is. They don't understand clean code, so they cannot care. Well, it's probably true. But should project managers, product owners, you name them, understand clean code? What do you think? Yes? No?
Yes, but hard to find.
Depends.
Well, do they understand memory safety? Well, even the NSA doesn't understand memory safety. How do you expect product managers to understand it? Do they understand concurrency patterns? Probably not. Do they understand the different forms of polymorphism? Well, I guess no, but I think that it's not a problem because it's not their job. They don't have to understand these things. Some of them they understand, but mostly because they were software developers before, not because they are product managers. Then there's the second group of answers. It's them, the junior developers. Well, they don't know how to code well. Yeah, we were all junior developers in the beginning. Yeah, we didn't know how to code well. Probably we still don't know how to code well. And we don't have the time to correct their code. It's probably true. They don't arrive with good enough knowledge. Well, define good enough. That's something that is very difficult to define, and that would lead to a third group, to the teachers. But I didn't want to blame teachers at all, so I skipped that slide. But maybe they just don't get good enough knowledge. But the problem, okay, that's not a problem, that's a fact. The number of junior developers is exploding. It's normal. We need more and more software engineers. So you see that in around 2018, we had something like 25 million developers, and now we are about almost at 30. And they say that by 2030, we'll have more than 40 million software engineers in the world. That's a lot of people. And we don't have enough mentoring opportunities for them, simply because there are not enough mentors. You see, there are so many people coming into the industry. You cannot, well, okay, probably our industry is the only one where you can become a senior engineer in like 1 year, 2 years, 3 years. You think, oh, okay, I'm a senior engineer. I saw a snake, and now I can write Python a senior way. Well, it's not really what what makes a good mentor. So we cannot have, we don't have enough mentors. We cannot mentor so many junior developers, yeah. But almost nobody said that it's us. Nobody said that, well, it's me the problem, it's me the problem. But in reality, it's us, it's senior developers who are guilty here. Why clean code is not the norm? Because the end, clean code is hard. And we must learn it. We have to learn it. It's not like, well, I write code for 5 to 10 years and then from one day to the other, I start writing clean code just naturally. It doesn't come that way. We have to learn it. It requires effort and discipline, almost like a Spartan. But people don't really make a lot of effort. They don't really have discipline. People, we are lazy and disorganized. Did I tell you that I forgot home my clicker? I forgot my adapter. We are lazy and disorganized. So it doesn't come naturally. And well, by definition, the average is average. So people tend to perform on a mediocre level. And at least for the time being, clean code is not part of the average. So we have to learn like how to raise the bar. And for that, I think we need systems in place. We have to show the right example. And well, maybe some of you will not like it, but I think we need social pressure. We need peer pressure. And with that, we can increase the bar. And we must do our job in order to reach that goal. But what is our job? What's our job as a software engineer? That's the next question. Well, we should write, I think, clean code, right? And we should write tests. But test is code. So let's remove that. You just write code, okay? Let's write clean code. And anyway, we said that clean code means that your code is testable and tested. So apart from writing code, that's well, we often say that's main job, but the more time you spend in the software industry, the less you will actually code. We also have to invest time into learning. I think we have to invest time into learning every single day, and hopefully we can do it in working hours. Even, like, you can do that in two different ways. Either you don't tell your management that, hey, I take off half an hour every day to learn something new, or you actually tell them. And their reaction probably will also show if you should spend there a lot of time. But in both of my, so both at Spotify and in my previous company, that was not an issue. They are really supportive in these terms. They even expect that you learn and you share your knowledge. I think that's really important. Now, the more time we spend in the software industry, the more that we have to communicate as an engineer. So his job is not only about coding. We have to communicate a lot. So let's see what are the different forms of communication as an engineer. We have to listen. That's probably the most important. I probably even have somewhere a sticker here. Yeah, listening is everything. And it goes both ways. Like listening to music, yeah, it's important, but listening to the others, it's even more important. We have to document a lot. We have to educate. That's also a form of communication. We don't only have to educate others, we also have to explain people why we do things in a certain way, why certain things are important. Especially we have to explain a lot to non-technical people. And learning how to do that is a very difficult skill, I think. But we don't only have to explain, we have to alert people that, okay, what you are going to do is probably not going to work in the long run and you shouldn't do that. Now, alerting is one thing, but in some cases, it's not enough. We must say no sometimes. We have to have a firm no in certain cases. You don't have to say no every day, but from time to time, you must say no. And think about this, like, I think that plan is not really going to work out well. So we have to remind the others about the truth, that what they want, what maybe the product owner wants, it's not going to work. And then comes the question, like, do we have a mandate? Do we have a mandate to say, no, I'm not going to do that? Do we? Yeah, we should. We should. And if you say no and they don't trust you, then you should probably be ready to go somewhere else where they will trust you. We'll get back to that a bit later. So what can happen if you say no? Well, maybe your objection will be heard, only heard. Okay, it happened to me. Maybe they will convince you that, okay, you said no, you really believed it, but you are not right. Because maybe you say, hey, we should not do that because it's really bad and it will hurt the business. But maybe they will object that, look, you're right, but if we don't go to the market very soon, well, there will be no market for us. And sometimes you have to make the sacrifice. So you might get convinced. Or they say, yeah, probably you're right, we don't care. So they just reject you. They might not even care reacting. Well, that's bad, but I guess all of us saw such cases. But okay, you say no. These are the different possibilities, but what can go wrong? What can happen? Well, I don't think that it can really go badly because it's just business, okay? It's not about personal differences. It's about business. It's about your profession. It's nothing personal. And, well, you know, if they take it personally, because it might happen, well, it maybe just show your way that you should be ready to leave and look for another job. I think we should do what we need to do. And it includes saying no, but sometimes it includes that, well, you just do the things in a way that you think that is the right way. Because after all, you are the experts here. You know how to do your job. So, do you tell your doctor how he or she should cure you? What do they think then?
They do what I ask because, yeah.
But is it the right thing to do?
Yeah, it was. Otherwise, I would be still waiting to be cured.
I know this is a discussion that I often have at home. If I go to a professional, I expect that they know the best ways to deal with certain problems. And I don't want to tell them how to do things. That's not why I pay them. And that's not why they pay us in our jobs, that they tell us how to do things. They should tell us what we should do, what we should achieve, but not the how. So I think that we should just do our job and not ask for permission to do it in a certain way. I honestly don't want my doctor to ask me okay, which cure do I, so how should I cure you? Well, you know the best. It's or when you take a cab. I went home to Hungary a few months ago. We landed around around midnight, and we had a 25 kilometers way from the airport to home. And the driver asked me 3 different times, which way should I take? You have a GPS. You know exactly where I want to go. Why I should tell you? I don't know. I don't pay them for that. So they also don't pay you to tell how to do your job. Do what you think is best. And I think what's really important everywhere in life, everywhere, but in our job as well, to leave the campground cleaner than we found it. Don't make a bigger mess. So what does it mean in terms of clean code? It's not enough to check in clean new code, I think. It's a good start, but it's not enough. I think that you should dedicate some time to clean up at least around. Now, I want to make that clear that I don't think that you should go on a month-long refactoring when you touch a piece of bad code. It's not sustainable, right? You don't have the time for that, and it would be really difficult to justify in any sense. But what you can do is always okay, just a little bit, you make things a bit better. Even just a couple of lines around. And in the long run, I think it will pay off in different ways. So in the long run, you will have a cleaner code base, but that's not the most important. The most important is the example that you show to others, that you can do a better job. You can change, you can transform a bad code base into a better code base, just by dedicating a little bit of time every day. Or not necessarily every day, but when you touch the code. Well, that's wishful thinking, touching the code base every day. So it's going to make a difference in the long run, I think. And for that, you need no permission. Now, we still have a couple of minutes, and just popped up in my mind that I saw a C++ educational video by Kate Gregory. And she was talking about a technique that I share with a lot of people who I meet. Okay, let's say you have to implement a feature, and you have 5 days to implement it. Let's say that's your estimation. That's pretty much the expectation. What can happen? What should we do? So you have 5 days. You spend the first half, 2.5 days, on refactoring a bit, cleaning up things around. Because maybe then you can implement the feature in a much better way. You can implement it easier. And then you will fit the 5 days. Now, what if you were wrong? Well, then at the end of the 2.5 days, so in the middle, you just cut, okay? You You check out the original state and you said, well, it didn't work out, so now I start from scratch as it was expected. And in the end, you spent 7.5 days on it instead of the 5. It would happen anyways, yeah? Like estimations are often bad, and if you do this, you will have more fun at work. Probably you will produce better code, and well, maybe you learn something. And if not, well, it's just the usual estimation error. Nothing can go really wrong with that. So my conclusion is that, well, yeah, quality is hard to define. We heard many different definitions, opinions, but still I think that clean code is part of software quality, and it's part of our job to make the things right. And it's our responsibility, it's the responsibility of senior developers, senior engineers to pass these values to the juniors, to the next generation of developers. We don't only have to share knowledge, we have to share also the right values of software development. So I have a call to action slide that when you go back at the end of the conference, you should, no, I shouldn't say that you should, but I'd be happy if you would explain this to your colleagues. Explain these things to your product managers, to the management, not necessarily only to product management, the engineering management as well. And set your limits. Like what can you expect, what can you accept from management, from product management, and what is that they say, okay, I don't take this. I don't do those bad things that you want me to do, and instead, well, I'll do it either my way or I go away. So be ready to say no. And at the end of the day, I think you will sleep also better if in these cases you say no. It's easier to take. And lead your colleagues by example. That's the best way you can lead, by example. Maybe it's slower, but I think it's more beneficial. So thanks a lot for coming to this talk. I hope you have something to take away. And if you have any questions, I'm staying.